Hey guys, today we're going to be talking about systems of equations and their solutions. We need to make sure we get this page down in our notes, so if you do not already have a pre-printed copy of this, you're going to want to give a rough sketch to drawing the graph as well as writing all of the descriptions on the left-hand side. So again, if you don't have a pre-printed copy of this, please pause the video and do that now. Okay, so as you can see on the graph on the left, we've got two linear graphs that are plotted on a coordinate plane. If you have two or more lines graphed on the same coordinate plane, the lines will always intersect, unless they're parallel. The intersection that you see here is what represents where each line will have the exact x and y values, and that's called the solution to that system of equations. We always write the solution as an ordered pair. So if we look at the graph that we're given on the left, what would be the solution to this system of equations? Remember, write your answer as an ordered pair. Yes, the solution would be, get my pen here. The solution would be right here where they intersect. So my ordered pair would be at +1, +3. So the solution to this system of equations is the ordered pair 1, 3. All right, let's look at these next three systems. We're going to give kind of a rough sketch on this in our journal or in our notes. So let's talk about that first one that we saw. We've got a rough sketch of our x and y axis. And we had our lines that went through. I'll make them a different color. We had one that went through here and maybe one that went through about right there. And you see they have that one point of intersection. That one point of intersection means that there is only one solution. There's only one solution because there's only one point of intersection. Now, let's go back and look at the parallel lines. Be thinking about where their solution would be. Again, let's go ahead and graph it. Let's draw a rough sketch in our notes. We have our x and our y coordinates. We have our two lines. And I guess to be proper, we should be making arrows, because the lines, they go on and on forever. A line does not stop unless it's a segment. Okay, so looking at this next example, if I have two parallel lines that keep traveling in the same direction, either side, are they ever going to intersect? No. So in this case, there is no solution. There is no solution in this case. Again, the first one we have one solution because it intersects at one point only. This one intersects at no points, so there is no solution. Now let's go back and look at this green graph. Looks like there's only one line, right? All right, well, let's draw it out. Back to my red. We'll sketch this out. Here's my y and here's my x. This case only had one line. But remember, in order for it to be called a system of equations, that means there has to be two lines or more. Well, if I only see one, well, what does that mean? That means that my two lines, two or more, they have to be laying on top of one another. So it's basically having this same exact line drawn twice. So if you have two lines that are on top of each other, where are they going to intersect? Where are they going to touch? They're going to touch at every single point, right? Every single point, no matter if it continues up or it continues down. So we could say that there is infinite solutions. Anywhere those two lines continue to grow, they will always be touching. So there is infinite solutions. Okay, just to recap here. One solution, there's only one point of crossing. No solution, they never touch. And infinite, or I guess we could also say many solutions, because there's a whole bunch of them. Any place on that line, they will be touching. All right, let's talk about this one. Now we're going to put it into a context. Trey is trying to find the values x and y that simultaneously satisfy both of the lines graphed. Which of the following ordered pairs is the best estimate for the solution? Well, in order to find that solution, change my pen back to red, I'm going to look for the point where they intersect, right here. And then what is that ordered pair? That ordered pair, if I'm starting at the origin, I go over on my x, -1, -2, -3. So that's at about -3. And then we went down -1. So then out of these four answer choices, B, -3, -1 would be your answer. All right, you try this one. What would the solution to this ordered pair be? That's right. If we're looking, here's my origin. So I go over to 10, and then I'm going to go up 5, 10, 15. Remember, we always want to look at the scale. What are we counting by? So the solution to this system of equations is the ordered pair 10, 15. All right, you try this one. Daryl is trying to find the values of x and y that simultaneously satisfy both of the lines graphed. Which of the following ordered pairs is the best estimate for the solution? Think about the ordered pair. Where do they intersect? Where do they cross? Where do they meet? Right here. What would be your best estimate for your ordered pair? Did you choose A? We're going to go over from the origin, 1, 2, 3, 4. And we're going to go up. This is 6. This is 7. So it's halfway between 7 and 8. So it would be the ordered pair 4 and about 7.5. And as you can see over here, they wrote it as a decimal. So 4, 7.5 would be the solution to this system of equations. All right, now this one we have a whole bunch of systems, but here they give us the solution. In the graph below, which two lines have -3, -5 as the x and y values that simultaneously satisfy both linear equations? Guys, that's just a fancy way to say which two lines cross at -3, -5. Well, let's go to the graph and see. I need to go -3, 1, 2, 3, and down to -5, 1, 2, 3, 4, and 5. So that point is on which two lines? It is on line A, and if I travel it up this way, it is on line D. So answer choice D, lines A and D, would be the answer to this problem. All right, so now we're going to get into what does the solution represent. So here we've got a graph, and we've got yellow cab versus blue cab. Guess people are taking a road trip. We've got the total cost on our y-axis, and we've got the number of miles on our x. So when you're looking at this graph, what does the x variable represent? Remember, when they say the word represent, that's talking about words, descriptions. Well, my x variable, in order to find that, I need to go and look at my x and y axis. This is my y, this is my x. So if I want my x variable, what is it labeled? My x variable represents the number of miles. The number of miles. All right, now you tell me, what does the y variable represent? Think about what's your label you're going to look at. If we label our axis y and x, my y variable represents the total cost. The total cost in dollars. So once we've identified those descriptors or what they represent, then we're able to answer a few questions. If someone plans to travel 2 miles, which cab is the better deal? Well, we're talking about 2 miles. So I'm going to go over here on my x-axis because that is the number of miles. I'm going to go over to 2. Who's going to have the better deal? Yellow cab or blue cab? Well, when I get to my yellow cab intersects that line at about $5. I keep going up, my blue cab is going to cost how much? $7. So which one has the better deal? Yes, the yellow cab. Because at 2 miles, the yellow cab is at a lower cost versus the blue cab at a higher cost. All right, what about this one? If you want to travel 8 miles, which cab is the better deal? Number of miles, we're going to go over to 8, and we're going to come up, we're going to trace it up, and we're going to see who do we get to first. Oh, in this case, the blue cab is first because it correlates to a cost of 12 miles. So the blue cab, or $12, excuse me. The blue cab costs $12, but at 8 miles, we can see the yellow cab is super expensive up here at $17. So who's cheaper? Blue cab, you got it. Now, will the cabs ever cost the same amount? Remember, the same. They want the exact values. Well, that's just where the point of intersection is. That's where they cost the same. That means at 3 miles, where we go down, at 3 miles, how much did they both cost? They both cost $8. So D, at 3 miles, they both cost $8. That would be representing that ordered pair, 3 and 8. The ordered pair here, 3 and 8. 3 was the number of miles. 8 is the number of dollars. Put that into words. You get your answer right there. Yes, at 3 miles, both cabs will cost $8. All right, what about this one? If you plan to drive 100 miles, who do you think is going to have the better deal? Whoa, 100 miles. Do I have 100 miles on my chart? I only go up to 20 miles. But can I look at the pattern of the graph? What's happening? The yellow line is super steep. So as we keep going, it's going to keep rising and rising. But the blue cab, his line's not so steep. So as he keeps going, he's always going to be lower. After 3 miles, the blue cab will always have a cheaper cost. Blue cab. All right, what about this one? What is the solution to this system of equations? Think back to the beginning of our notes. What is a solution to a system of equations? They didn't ask us to represent it or describe it. So solution, as you can see by most of our answer choices, it's an ordered pair. So again, to find the solution, where do they cross? They cross at the ordered pair 3, 8. 3 and 8. Be careful. Don't choose this one. Don't choose E. E put it backwards at 8, 3. So those were just some quick notes about system of equations. Once you have these all down in your notes, then you'll move on to today's practice activity.